Alrighty, welcome everyone to our webinar today, Process Safety and Functional Safety, a Tale of Two Disciplines. So my name is Patrick O'Brien. I'm the Assistant Director of Engineering at Exida, and I've been with Exida for a little bit over 8 years now, have had the chance to work in a couple of different roles, everything from strict process safety consulting, looking at doing hazard and risk analysis, PHAs, LOPAs, HAZOP, as well as getting involved on the functional safety side, looking more at the design and requirements for safety instrumented functions and safety instrumented systems, and how organizations can implement those as one way of reducing risk. I've also had the opportunity to get involved quite a bit in cybersecurity, so really making sure that those critical control and safety systems aren't manipulated by attackers. So have been able to see a lot of different sites, a lot of different parts of the industry. And for today's webinar, we're going to jump in and really try to answer some fundamental questions about process safety and functional safety. And the idea for this webinar came as we were working with a couple of different sites, and we're seeing that the distinction and the understanding of where process safety stops and functional safety starts is not necessarily clear. Not everyone has the same view on it. And there are certainly some misconceptions out there on how these groups need to work together. And so ultimately, we'll see that process safety and functional safety are both needed to protect chemical facilities from hazardous events. It's not an either or, it's not a competition. Really, we need both of those disciplines. But we'll start with looking at some of the fundamental or core safety concepts for process safety. Try to get that background to understand when we talk about process safety, exactly what are we talking about. Next, we'll look at some core concepts for functional safety, understanding the safety life cycle, how it was developed over time. And then lastly, we'll come back and look at practical implementation of process safety and functional safety, thinking about really where are those two disciplines aligned, where are there some differences, so that we can make sure that we're effectively managing risk for our facilities. And so to get started, I want to start with a very basic question, right? What is safety? It's something that, in the field, we kind of talk about safety without thinking about it. But when you go to a dictionary definition, there are a couple of good ones out there that make me chuckle. One that I see a lot is the condition of being safe. That really doesn't tell us a whole lot. If we look at the IEC 61511 definition, it is freedom from risk which is not tolerable. Now, to really get the most out of this definition, it kind of leads to some follow-up questions. So, well, what is risk and what is tolerable risk, right? What are risks that we can accept or not accept? And so to dig just a little bit deeper here, so risk is the probability of occurrence of harm and the severity of that harm. It's our likelihood and consequence. How often can something bad happen? And if it does happen, how big will the impact be? If we think about a slip hazard, someone who's an adult is probably going to have a lower probability of slipping and falling than a young child that's running around, right? So we might have a difference in likelihood there, but the severity of both of them could be a bruise or a cut, and so that together gets your risk of that fall scenario happening. And when we then try to think about tolerable risk, this is the level of risk which is accepted in a given context. And that acceptance is based on current values of systems. And because of that, because it is value driven, it can vary by region, by industry, and over time. So risks that were broadly accepted and not thought about 40 years ago are not necessarily acceptable today. And we're seeing that the industry as a whole is trying to move and reduce risk. So there's more drivers to try to bring that risk level lower. And ultimately, in many cases, companies are the ones who set that criteria for tolerable risk for their organization. In some cases, the regulator or the authority having jurisdiction may also influence where that tolerable risk is. So with that in mind, we can think about safety being the activity of bringing our risks down to an acceptable level. And so understanding what our consequences are, and then applying enough controls to bring those risks down to a tolerable or an acceptable level. And so with that definition in mind, we have to think about how companies manage the risk and really how they look at this. And so ultimately, companies have a legal, moral, and a financial obligation to limit the risk posed by their operations. And so if we start with the legal side, right, for any companies operating in a country with process safety regulations or general safety regulations, they have a legal requirement to follow those regulations. And if they don't, they're open to legal action, potentially significant fines, or the loss of operations. So they have, absolutely minimum requirements that they must comply with. Now, if we take that to the extreme, and the only thing that a company looked at was the regulations, and they didn't think about risk at all, right? They could follow the regulation to the letter of the law. They could do exactly what it says, and they could be missing something that's not in the regulation and really not be operating safely. They might not be fined for it, but they could have lost production, they could have downtime or other safety impact. On the financial side, there's always a driver to try to optimize the, let's say, the profit or the money that is being made for a site. And so in theory, if you built the lowest cost plant, you kept the operating budget as small as possible. Now you could do the math and you'd say, hey, for the next year, this is going to maximize the profit that we get for this facility. The problem there is that over time, not keeping up to date on maintenance, not having the safeguards in place is going to lead to downtime, is going to lead to loss events that are going to be a significant cost. And then lastly, from a moral standpoint, we might think that out of these, doing the moral thing, making the plan as safe as possible without thinking about costs, might be the best approach. But in that case, if there's no consideration of the possible cost of implementing controls, you would basically design a site that was inoperable, right? There'd be no way to make product or make any profit from that site. And so then you don't have jobs for people, you don't have the societal benefit from having that product available. And so it's really only when companies are able to find that sweet spot in the middle, where they're complying with minimum regulations, they are taking the necessary steps to limit downtime and reactive maintenance, and when they're doing what is required to meet a moral obligation and provide a safe work environment. And so really, risk management in the process industry requires that we're aware of all of those drivers and find that middle ground. Another important thing to think about of why safety is so important for the process industry, and to push back on some of the financial arguments that are pushed at sites is, there's that old saying that if you think safety is expensive, try an accident, right? So whatever the cost is of those upfront safety activities, if you are in the unfortunate incident where there is a significant process release, the cost of that is going to drastically outweigh the cost up front of the safety measures. And so this was something that was really a calling card. And Trevor Kletz, one of the founding fathers of process safety, had this among many other famous quotes, and really thinking about how can we limit those low likelihood but extremely high consequence events that still have a high level of risk. And that's one of the key considerations for process safety. And so if we try to dig into safety a little bit deeper, and instead of saying what is safety overall, say what is process safety, it is the prevention of fires, explosions, and unintentional releases of hazardous materials for chemical process sites. Or to kind of put it in the framework of the first definition, it is bringing the risk of a fire, explosion, or unintentional release for a chemical site down to an acceptable level, right? So analyzing the hazards and then ensuring that there are sufficient mitigations and protections in place to bring that risk down to a tolerable level. Now, there are a lot of kind of key activities that go into process safety. There is process safety management, everything from management of change to getting employee buy-in and building competency within the organization, to doing the detailed hazard and risk analysis, HAZOP, LOPA, understanding quantitative risk assessment. So there's a lot there that we'll see in process safety that is a significant overlap with the analysis phase of the functional safety life cycle, which we'll get to a little bit later. And as we look at process safety, this is really something that has evolved and grown over time. And if we go back to the 1980s, there were a series of major process safety incidents that had significant public impact, significant attention. The most famous is probably the 1984 incident in Bhopal, India, a truly tragic release, very high loss of life. And it was a huge wake-up call for the industry as a whole. And so following those major industrial accidents, Piper Alpha being another big one in the UK, there was a big shift towards more stringent regulations for process safety, starting in the late 80s and the rest of the 90s. In 1989, the EU Occupational Safety and Health Framework came out. The MSIHC in India came out as a direct response to the Bhopal incident. In 1990, OSHA PSM was first released in the United States. The Seveso II directive was updated for the EU with some significant changes. And we started to see at the end of the 90s and early 2000s, the first functional safety standards come into play. And that doesn't mean that, in the 90s, we had regulations come out and that was the stopping point. We've really seen from the 2000s on till today that companies are continuing to adjust and try to optimize and improve how they're implementing process safety for sites. So looking at things like total quality management, where safety is not just a regulatory tax that you need to do, but looking at safety as an opportunity to improve the overall efficiency of a site. So are there ways that we can cut down on downtime by operating better within our normal operating range, having fewer deviations? Looking at continuous improvement approaches of how can we continue to make that process better over time? How can we improve our management systems, improve our operational capabilities? And then lastly, going to the CCPS risk-based process safety framework, which is really using risk as that core driver for what activities we need to focus on, what we need to do first. And so if we take just a little bit of a deeper look at a few process safety regulations, this is certainly not a complete list on here, but just showing a little bit more details for those that we mentioned on the last slide. In the US, we have OSHA PSM, which has 14 key elements for process safety. We'll look at those in a little bit more detail on the next slide. But this applies to facilities with any one of over 130 chemicals above a threshold quantity defined for each of those chemicals. In the EU, there's the Seveso directive. It's now up to Seveso III, which applies to over 10,000 sites in Europe. And what's interesting to be aware of with directives is that each member country is responsible for enforcement. So although it applies to every country in the EU, the way that it is enforced or applied in Germany may be slightly different than how it's applied in Italy or the Netherlands. And so it is important to understand how it's handled within that jurisdiction, because that's going to change how companies need to implement or how they're audited on process safety. In the UK, the control of major accident hazards is enforced by the Health and Safety Executive for non-nuclear facilities. It follows a safety case approach where they are really looking to see that documentation on that reporting of what the site is doing to maintain safety. There's a lot of documentation that they are looking for there. And then in India, as we mentioned, following the Bhopal incident, the manufacturer, storage, and import of hazardous chemical rules has some specific guidelines around classifying hazardous chemicals, reporting requirements, auditing requirements, and emergency planning. And this is certainly not to say that those are the only process safety regulations out there. There are a number of countries like Canada, China, Japan, who have some specific process safety regulations as well. And for those countries who don't have process safety regulations, that doesn't necessarily mean that companies can do whatever they want. There's typically still general duty clauses for protecting workers and public safety. And so even if a country doesn't have that specific process safety regulation, if there's a major incident, if there's clear negligence, there may still be fines, legal consequences, in some cases even prison time as well. And so what we'll do is we'll just pick out OSHA PSM is one that I'm honestly a little bit more familiar with than some of the other areas, and look at some of the key elements of what's included in the PSM requirements. And we'll see there's some color coding here to map onto risk-based process safety on the next slide. And so to start, there are some basic things like employee participation, getting buy-in within the organization, making sure that the employees who are exposed to the risk are included in the decision-making, are present at meetings where risk is discussed. Also some requirements around trade secrets, where in the past, some companies would try to hide details of the process, saying that it's a trade secret, that they couldn't share that information with employees. And really this comes down and says that if that aspect of the process has safety hazards, the people exposed to those hazards need to be aware, they need to be able to discuss and understand what hazards they're being exposed to. Next, there are requirements around making process safety information available for all of the chemicals within the site, so that when you do the process hazard analysis, that again, everyone there has access to that information and can understand what sort of hazards they may be facing if there is a release from the site. Whether it's understanding the potential impacts for that concentration of ammonia, potential consequences associated with hydrogen, or any of the other chemicals that are located for that site, it's critical that the people doing the risk analysis are aware. Next, there are the ongoing activities that are really required to manage risk. Some of these really go more into the operations and maintenance phase, thinking about having safe operating procedures, training for employees and contractors, ongoing mechanical integrity programs for, testing pressure relief valves periodically, inspecting pressurized vessels. And again, all of this goes to manage that risk over time in operations and make sure that we aren't seeing increased risks over time. And then lastly, there's a requirement to conduct incident investigations and periodic compliance audits to again have that periodic check as part of the process safety program, make sure that we're digging down and really finding root causes as opposed to just contributing factors or the last thing that went wrong before an incident or a near miss. And so if we look at the risk-based process safety framework, it's taken those 14 elements from PSM, considering other regulations in the world as well, and really built out 20 elements based on 4 pillars for managing or for building a successful process safety management system. And so it groups those elements into the pillars, starting with committing to process safety, really that foundational building block of if you don't have the right culture, if you don't have the right awareness and competency within the organization, you're not going to be successful going further in the life cycle. From there, once there is that buy-in, those foundational capabilities, the next step is to understand the hazards, assess the risks, and understand what protections need to be put in place. Once you know what the risk is, you need to manage it. And so, looking at the safe operating procedures, looking at how contractors are managed, management of change is done, making sure that things and the system and the process is ready for startup before you begin operations. So thinking about all of those things that need to be done over time to manage that risk. And then lastly, learning from experience, building more than just incident investigation and auditing, but also looking at collecting specific metrics on the performance of different systems, looking at leading and lagging indicators of potential releases, making sure that you're not just waiting until you have that major incident to respond. And thinking about implementing more of that continuous improvement type approach for process safety. And so we can see that over time, the way that process safety has been managed has also evolved. And in the beginning, it was really more of a standards-based strategy where companies would have prescriptive design standards, where for a given type of unit or a given type of plant, they would have some outlines of what you should do for that type of plant. Maybe there is a process where they knew it had a decomposition hazard, and so they had one high temperature SIF. But it was only looking at certain conditions. It wasn't really a holistic risk assessment for that facility or for that unit. And following those high-profile accidents, really in the 90s, the industry or the regulators realized that it had to move to at least a compliance-based approach, which is, what do I have to do to meet minimum regulatory requirements? So this could be, in the US, for example, just having a program that letter of the law meets OSHA PSM, covers just those 14 elements and nothing else. But it's important to realize that the industry didn't stop there, because safety is not just about complying to that minimum regulatory requirement. It's really about managing risk. And so many companies moved to more of a continuous improvement based strategy. So looking at how could they improve their processes and safety systems over time. Were there opportunities to move to an inherently safer process over time? Were there opportunities to change the way that they did incident investigation and get better results out of it? And really learn from their own experience. And then lastly, moving to a risk-based strategy. The question here is really, how can I better manage risk? So it's not just learning from an individual site's experiences. It's growing and looking at the industry as a whole, seeing what best practices are out there to improve how risk is managed to continue to drive that risk lower for the facility, for the organization, for the industry. And risk-based process safety is really a key framework for moving to that higher maturity level. Now, from the functional safety side, we can also think about really trying to understand the definitions, see where this fits in relation to process safety and safety overall. And so the definition in IEC 61508, which is really our parent standard for functional safety, is that it is part of the overall safety relating to the equipment under control and the control system that depends on the correct functioning of electrical, electronic, or programmable electronic safety-related systems and other risk reduction measures. Now, if you're reading that and have more questions than answers, I would say you're certainly not alone. I think the way the definition is written is very problematic, even for highly technical people. So what I will propose instead is a slightly more plain English definition. And we can say that functional safety is the portion of safety for using electronic safety systems to protect physical equipment. Those electronic safety systems could be hardwired relay based, they could be safety PLC based, but it is something that has an electrical component that is being used in a safety system. And used in the safety system for physical equipment. Now, that could be a process plant or a chemical site, but it could also be a robotic arm, it could be a mode of transportation, a medical device, but any sort of device that's interacting with the physical world, if it has a safety system or safety functions, those are really going to fall under functional safety. Similar to process safety, functional safety has certainly evolved over time. So if we start back in the 60s and 70s, in the 60s, safety was really only identified in certain applications where it was recognized, likely driven by a company design standard, and it was only done using hardwired relays and relay logic. And as we moved to the 70s, solid state devices started to become more popular. People had the great idea that these solid state devices are more reliable than relays, so that has to be the best solution for having a better safety shutdown. We also started to see that some of the risk analysis techniques from the process safety side begin to be used, but it was still very much company specific, only where a need was recognized. It wasn't a comprehensive implementation. And we saw that the move to solid state devices really didn't lead to any improvement in performance. When they had thought that they were more reliable, they didn't think about the difference between safe and dangerous failures. And so hardwired relays tended to fail de-energized, which was a safe condition for a trip, whereas the solid state devices had actually a higher portion of dangerous failures compared to safe failures when looking at the relays. So it ended up not making systems any safer, potentially making them less safe than what they were before. In the 80s, now programmable logic controllers and PLCs started to be used to replace both the solid state and the relay-based systems, but there was no standards or guidelines for safe software yet. And even though the risk analysis procedures were getting a little bit more sophisticated, studies showed that there was still no decrease in accident. There was continued significant losses and major process safety events. And so the industry continued to try to push forward. In the 90s, some safety PLCs with a designated safe subset of software were being developed. The very first standards for PLCs started to come into play, and our risk assessment approaches got more sophisticated. And in the 80s and 90s, we saw that the safety design process followed a couple simple steps. So the first was to identify potential hazards, then determine how significant the consequence was for those hazards. And based on that consequence severity, then a set design guideline would be followed. And so if any class 3 hazard, which was a serious injury or fatality, occurred, the design would then be to use 3 transmitters voted 2 out of 3, a safety rated PLC, and then a new solenoid, safety solenoid, to trip the existing control valve. And we'll look at why this prescriptive design was so problematic in a few slides. But we still weren't seeing the improvement in accident rate, right? There was still more that the industry needed to do. And so there are a number of really key safety standards that were being worked on at this time. EN 954 was really one of the key documents for machine safety. That's been replaced by 2 modern standards for machine safety. IEC 61508 as the really parent umbrella standard in the late 90s, being released for IEC 61511 for the process industry in early 2000. So a lot of documents starting to come together and kind of change what was looked at in the functional safety industry. And as we can see, moving forward to the 2000s to today, there have been some significant improvements. There is much more safety equipment available now than there was in the past, not just the safety PLCs, but the transmitters and valves as well. And really for each decade, we're seeing more and more equipment becoming safety certified, greater adoption among both end users and manufacturers, and seeing that there are now more choices out there for getting SIL certified options. And so if we look at our current functional safety standards, we have IEC 61511 or 61508 as that parent umbrella standard that applies to all industries, requirements for manufacturers, requirements that can be broadly applied. And then under 61508, we have some segment specific standards like IEC 61513 for the nuclear sector or 62061 for machinery. Or the one that we'll really talk about for the rest of our session is IEC 61511, which is focused for the process industry. In the past, the US used to use ISA 84, which was a mod of 61511, but now those two are fully aligned, so there's no more grandfathering. And so IEC 61511 is a subset of those 508 requirements that really focuses in on the process industry. It tries to take the larger standard and make it a little bit more practical for use. And so really what we're doing is narrowing the scope. So the equipment under control that we're talking about is focusing in on a process facility. And we're looking at the safety instrumented systems which are the electronic-based safety systems for that process plant, and making sure that there are adequate controls in place to bring the risk of an upset at that process facility down to an appropriate level. And in IEC 62511, it identifies our safety lifecycle, which is really key to making sure that those safety instrumented systems are managed properly over time. And there's some significant overlap here between functional safety and process safety. So the management of functional safety is something that needs to be done across the entire life cycle, and the core areas of building culture, establishing competency, establishing guidelines for compliance and internal audits, all of those things that need to be done to roll out a safety program are very similar between what process safety is requiring and what functional safety is requiring. Similarly, within the analysis phase, doing the hazard and risk analysis, identifying where safety functions are needed, what protection layers are in place, and defining requirements is a very common process between process and the functional safety sides. Where 61511 starts to get into a little bit more of a specific detailed focus is on how to design and build those safety systems. So what are the design requirements? How do we assess the performance of those safety functions and make sure that they are adequate, that they've been installed correctly, and that we're testing them periodically? And so that continues what we need to do past design and implementation and into the operations and maintenance phase. And very similar to how the process safety management approach has evolved over time, the way that companies manage functional safety has also evolved. So we've moved from a prescriptive standards-based strategy where you look at the consequence, and based on that consequence, you have a set design that you'll use for every safety function, regardless of application, regardless of what type of condition you're protecting against. Think back to that old 2 out of 3 AK6 safety PLC design. That would be an example of a prescriptive approach. We then moved to more of a compliance-based strategy, looking at the requirements in IEC 61508 and IEC 61511. The key is that those standards are performance-based. So it doesn't specify a set design you need to follow, but it does specify how you assess the reliability and the safety performance of that safety function to make sure that it is adequate. And over time, companies have continued to increase the maturity there, thinking about continuous improvement strategies of trying to gather that performance metrics for the SIS and safety functions over time, looking at opportunities to improve the design of the system and improve their overall approach. And then on the highest end of maturity, thinking about really more of an integrated risk-based approach. So not just looking at functional safety in isolation, thinking about how a functional safety program aligns with the process safety program, looking at, are alarms being managed, right? If we're going to take those as a protection layer, are operators able to see to and respond to those abnormal conditions, or are they going to get, hundreds of alarms in a couple of minutes when there's an upset scenario? Also looking at how cybersecurity, making sure that critical control and safety systems are protected, falls into that umbrella of overall facility risk management. And so thinking about that integrated approach is really the higher level maturity that organizations are striving towards. And so if we compare, right, to the earlier or less mature stage with prescriptive designs, we saw that companies were having wasteful over-design on the sensor and logic solver portion, where they were putting in lots of instrumentation, buying very expensive PLCs, and then connecting that with one new solenoid to an existing control valve. And the problem here was that if your initiating event was a control valve failure, so let's say you had a high temperature concern, and it was that your temperature control valve was the issue that was allowing the process to get too hot. If your safe state was to close that valve and stop further heat addition, if that valve is your failure, you're never going to be able to address that concern with this safety system design. So it was, spending a bunch of money on the front end without any actual risk reduction benefit for the site. And so the standards have moved away from that to a performance-based approach, where depending on the level of risk, a safety integrity level from 1 to 4 is specified for the safety function, really defining how robust or how well that safety function needs to perform its job of managing risk. And so that safety integrity level can be identified per an individual safety instrumented function or SIF, and that could be a high temperature SIF in our example. And so looking at the reliability of your safety transmitter, your logic solver, and your independent final element, and looking at how reliably can that bring your process to a safe state. And then our system as a whole is our safety instrumented system, or our SIS. So an SIS is comprised of multiple SIFs that may have different SIL targets, but each SIF is responsible for protecting against one hazard scenario, and your SIS may have many SIFs within it. And so now that we have a better understanding of really where process safety is focusing versus functional safety, we can go back to that tale of two disciplines and really try to understand, where do they overlap, where are they similar, where are they different in key areas. And so to start, we'll work on really visualizing that overlap. And so everything that we've talked about is in the realm of safety, but there are plenty of things to be safe that don't fall under process safety or functional safety. Being aware of insect or animal hazards, severe weather hazards, health hazards. There are certain things that we have to do to maintain safety, lower the risk of those undesirable events that are totally outside of the scope when we talk about process or functional safety. And then within safety overall, plant safety, or the things that we need to do to limit the risk of injury on a facility, is a subset of that. Process safety is a key part of that, but it's not the only thing we have to do for plant safety. But it does include things like hot work permits, trade secrets, but it does include things like looking at slip, trips, and falls hazards, making sure that any occupied buildings or working conditions are safe. We can't have operators in a control room that's 100 degrees. That's not going to be a safe condition for them. So there are things for facility safety that fall outside of the process safety focus. And then when we add functional safety in, there are some key areas of overlap, like hazard analysis, training, and competency, that are shared between process safety and functional safety. But there are also a lot of areas of functional safety that are outside of process safety. Looking at safety for trains or braking functions, those are things that are very much in the heart of functional safety, but a totally different segment, totally different focus than the process industry. And there are also some areas of functional safety that are outside of process safety that could still have an impact on plant safety. Those could be things like the processes that equipment manufacturers are following when they develop their products. Could be machine safety considerations. Many chemical sites will have packaging facilities to ship product once it's been completed, and the hazards of that packaging system or any sort of robotic arms are going to be very different than process hazards, and typically that requires a different type of risk assessment to identify and protect against those hazards. And so there are some areas that are relevant to plants that are outside of that process safety overlap. If we zoom in on the interconnection between process safety and functional safety a little bit more, we can see that there is a lot going on. There's a lot that we need to do for both of the standards, but there is a common spine running between them. So having the right company safety culture, having management systems in place, doing training and competency, that is absolutely fundamental to both process safety and functional safety. If we don't have those core building blocks in place, there's nothing that we can do that's going to be successful implementation. The hazard identification and risk analysis, identifying what protection layers we need, identifying if any of those are going to be safety functions, that is also common in our analysis phase between process safety and functional safety. And the steps and things like periodic audits, trying to learn over time and improve, all of that is very similar between the disciplines. But the focus of what we look at in detail is a bit different between process safety and functional safety. For process safety, we could think about the process design and engineering. So can we move to an inherently safer process? Do we need to change the temperature at which we operate or use an alternate chemical compound? For SIS design and engineering, we're looking at the equipment selection for our safety system, how we design the logic, and so it's very focused for those electronic components. For plant and process installation and commissioning, are we installing check valves the right way? Are PSVs sized correctly and installed correctly? For the SIS, it's are we installing those safety functions correctly? So we can see, although the life cycle steps, the activities that need to be completed are very similar, the focus of those activities will be a little bit different from process safety to functional safety. And as we try to put it all together, right, if we think about our environment as an operating plant, we could generally say that functional safety is a subset of the overall process safety activities, right? So within our overall process safety management plan of building competency, building culture, and analyzing and mitigating risks, functional safety is going to be the subset of that program that deals with safety instrumented systems. And so with that in mind, the process safety part is key for having those core functionalities, having those programs in place. And the functional safety is key for having those detailed guidance and detailed guidelines around how we design, how we implement safety instrumented functions to make sure that we're getting appropriate risk reduction from them. Because we are taking a lot of credit for them in our risk reduction. If we haven't implemented them correctly, we could have some significant risks that we're not aware of. And so it's really those two areas working together that is critical for a site. And having a really mature process safety program, right? Things could be looking great on that side of town, but we might have not the right maintenance requirements. We might have poor design awareness of how the safety instrumented systems have been built. And so we could have a very immature functional safety program at the same time. We could also have a site that maybe due to the personnel they have, they've got someone who's really familiar on the functional safety side, and they know all of the requirements, they're familiar with the standard, but they have a poor process safety program. And in that case, if the right hazards haven't been identified, then the safety functions aren't going to be protecting against the right risks. So it's only when we have both sides of, or both disciplines working together that we can really achieve our safety goals, right? Thinking about bringing that risk down to an acceptable level. And so we've got to keep that in mind, that it's not a one versus the other. It's not an either or. It really is both, the process safety discipline and the functional safety discipline working together, having a program that covers both aspects. And it always starts with, safety, culture, and competency. If we don't have buy-in, nothing that we have talked about as a technical control or risk assessment approach is really going to make any difference. It's only once that safety culture and competency has been established that we're going to be able to make progress. Some important questions to think about as you kind of gauge where your organization sits with this is, does your organization understand the difference between process safety and functional safety? Are the roles for process safety and functional safety clearly defined? Is it understood who owns, doing a risk assessment versus management of change versus, periodic testing of a safety system, right? Because your SIS may be very different from what testing needs to be done for PSVs or periodic vessel inspections. So really making sure and saying, hey, have we covered all of these areas? Do we have competent people assigned to them? Do they know that that's their responsibility? And for a lot of companies, if they're not totally sure where they stand, or want to get a little bit better understanding of where they are, a gap assessment can be a really good place to start to see what activities are getting done well, what activities are being missed, what are those rooms for improvement. And having that gap can really help build a roadmap where you prioritize goals, based on risk, right? What are the highest risks to our organization or to our program implementation? And a lot of times that will lead to better buy-in and more efficient rollout over time. And so we've got just a couple of slides to really look at some ways that Exida can help with this. And then we should have around 5 to 10 minutes for questions. And so if you do have any questions, there is a chat functionality. Please don't hesitate to put those in now, and we'll go through and discuss those with the group. But as we look at this, really functional safety is something that has been core to Exida since its founding. And we work with companies in a number of different ways. We work directly with the manufacturers for safety components to do assessment and certification that they meet the requirements of IEC 62508, or to IEC 62443 on the cybersecurity side. From the enterprise tools, we've developed the Excellentia tool, which is a full lifecycle tool, everything from process hazard analysis to LOPA, SIL verification, operations and maintenance tracking, all of those activities that we need to do for the functional safety lifecycle. And then we also have lifecycle services where we can work directly with operating plants to help them achieve their safety goals. And so with that, we've worked with a lot of companies as they start to develop and build out their functional safety programs, as they're trying to define those interfaces between process safety and functional safety. And depending on where an organization is, there are different ways that we can help. For those companies who are really just getting started, building competency is a great first step. So we have a lot of free reference material from webinars like this, blogs, white papers. We also have reference books that can be purchased, training courses available, both instructor-led and self-paced online, to build that competency, build that understanding within the organization. We can also help by doing gap assessments, really trying to understand where the organization currently is, what are those key areas to focus on, or lifecycle services, where if you have a specific process hazard analysis that needs to be done, or a safety instrumented system that needs to be analyzed, see how well the SIFs are performing, we can absolutely help with that and help address some of those key challenges. And so really think about where your organization is and what steps you need to take to build that maturity of the program. And so as I mentioned, training is always a great place to start. We have a number of upcoming training courses, both in person and online. And if you are really looking to get started in functional safety or ramp up the program, the FSC 100 is a 4-day course that really goes through the full 61511 life cycle and is a great place to start. We also have quite a number of online self-paced training courses, which are great to go through as well on your own time and build that competency. And so if you are interested in seeing future webinars like this, or want to stay up to date on the latest, please follow us on social media and subscribe to get those updates.